Much of the erosive power of the sea is produced by over 3 million waves that strike this coastline every year. Much of the erosive power of the sea is produced by over 3 million waves that strike this coastline every year. These waves are created way out at sea, where the wind blows over the water's surface, creating friction and changes in pressure. This pulls the crest of the wave up and pushes the trough of the wave down.
This makes the water begin to roll in a circular orbit, which creates a wave as it travels along. The size and energy of waves is dependent on three things: the strength of the winds, how long the wind has been blowing for, and the distance of ocean over which the wind blows and the waves build up. And we call this the fetch. For example, the southwest coast of England has a huge fetch of thousands of miles. Across the Atlantic Ocean, the waves build up, and this is why Cornwall and the southwest of England is a really good place for surfing. Here on the northeast coast, the fetch is smaller, around 500 miles across the North Sea, which is why this area doesn't receive big waves as often as we see in the southwest.
As waves move from deep to shallower water, they slow down, get steeper, and become closer together. In other words, they develop a shorter wavelength. The circular orbit of the water squashes together to make a vertical ellipse, where the top of the wave catches up with the bottom. And when the wave gets too steep, it breaks onto the shore, just like these.
The broken wave produces a swash of water up onto the shore and a backwash as the water flows back towards the sea. The swash has the constructive effect of carrying material up onto the shore, while the backwash has a destructive effect of dragging material out into the sea. So depending on the characteristics of a wave, it may remove material or deposit material on the shoreline. When the swash of a wave is more powerful than its backwash, more material is deposited on the shoreline than is pulled out to sea. We call these constructive waves, and they produce a flatter, more gently sloping beach profile. Constructive waves tend to be smaller in height and longer in wavelength.
When the backwash is more powerful than the swash, more material is removed from the beach than is accumulated. We call these destructive waves, and they tend to be higher with a shorter wavelength, and they create a steeper beach profile.
When the waves approach and break onto the shore at an angle, the swash is driven diagonally across the beach, while the backwash flows straight back out to sea under the influence of gravity. This produces a cross-shore current, which transports sediment down the coast in a process called longshore drift.
Now we can see the constructive and destructive effect of waves moving sediment around the beach. Before any material can be transported by the sea, natural processes first have to convert intact rocks in sea cliffs into lots of small particles that can be moved around by waves. This happens through two groups of coastal erosion processes.